Thanks. Thank you all for attending tonight. Pterofin is an early-stage company working on renewable energy technologies that are based on biomimicry, the study of birds and fish and how they move through air and water. I started the company a year ago to commercialize technologies which I believe are going to be true breakthroughs, and I'll get back to that. First, I'd like to tell a story about how I got to where I am and this company. The first thing you need to know is that I'm an inventor. I haven't always considered myself an inventor because I technically still don't have a patent issued to my name. But when people would find out that I was selling shares to a C Corp, they would ask what business school I attended, or if they heard I filed a patent, they would ask what engineering school I studied at. And the answer was always the same. And that was the school of life. My parents, the truth is my parents couldn't be any happier that I finished college. They didn't really care what I did. As long as I graduated, they were going to be happy. My passion in life was basically just building stuff. I remember one year for Christmas, I got a shoebox full of tape, and I was so excited thinking that the possibilities of creation were endless. So I started building stuff with blocks, and then moved to Legos, and then wood, and steel, and then aluminum, and now I'm vacuum bagging composites. So the first time I was asked to speak about my experience starting Pterofin, I began to realize that most of the projects I started were rather ambitious and somewhat impossible at first. But the longer I worked on them, the more I began to envision a finished product. So what you're looking at is a leg and hip joint to a bipedular aluminum robot that I was hoping to someday see run. And this is a 16-foot wingspan, high-speed glider, or hang glider, I guess you can call it. It only took me about 5 years to finish, and I hand-stitched all the fabric that went around it, or the canvas, but for some reason I'm having a hard time finding a test pilot, so if anybody knows, anyone? Okay. After working several jobs in several different industries, I finally settled down in Santa Barbara. And I was working at a golf course part-time and a personal trainer part-time, so I had plenty of time to work on my projects and golf and enjoy all that Santa Barbara had to offer at my age. And about 6 months passed, and the more comfortable I got with life, or I became with life, the more I felt the urge to really challenge myself and make a difference in other people's lives. So I've always been interested in fish and birds and flight, but water, the movement of water was always very fascinating to me. It was almost hypnotic. So I think there's nothing like a great puzzle to solve, but I also wanted to take on a project that would keep me up at night and not end up reinventing the wheel like I did so commonly. So, that was the front view of the first prototype I made. This is the top view, and as you can see, it had more moving parts than a car, and although it was really cool looking while it worked, it wasn't very efficient at all. And I skipped over something. Oh, it was basically an attempt to reverse engineer the rear fin of a fish. As it oscillated back and forth, it propelled itself forward. So I was trying to, instead of propel something forward, generate electricity by turning a generator. So here's the top view, same thing, yeah. So after revisiting the drawing board a few times, I created a single wing that could warp using counterweights that hinged from the lower portion of the arm attached to the wing. You can't tell what this is, can you? Yeah, so there's a counterweight here, and the wing went around the structure up there. Thanks. Once I dialed in the timing to the counterweights, I needed to construct a wing that was flexible in some areas and rigid in others to create a dynamic airfoil. So several prototypes later, I simplified the counterweight system to just a flat 2D wing, and there was only one counterweight, and it basically just pitched the wing clockwise or counterclockwise. So After the aha moment, I filed a patent with a local patent attorney named John Janeway at Janeway Patent and Law up in Ballard. And by the way, that last prototype, when I finally got it to work, it worked rather efficiently in front of a fan about 20 feet away on the lowest setting. It really kind of moved, and I knew I was onto something. So that was the aha moment. And then I started to, after I moved up to Seattle, I started to attend SCORE counselor meetings, which is, if you know what SCORE is, it's through the Small Business Administration. I had this patent, I knew I had to start a business or do something with it. So after about the seventh or eighth meeting with the SCORE counselor, he was being shadowed by a trainee who mentioned the competitions at UW that he just graduated from. It was a young guy. Usually these SCORE counselors are retired folk. And he introduced me to Pam at the Center for Entrepreneurship at UW. So, whoops. A few months later, there's SCORE, sorry. Yeah, great resource. A few months later, I had assembled a team and we won the second runner-up at the Science and Technology Showcase. And this is the prototype that we built. It's at the Kierson Wind Tunnel. And if you'd like to advance the slide one more time. This is a video that should play, maybe, yes. So a few months later, the team grew, and we won the Honorable Mention Award at the Environmental Innovation Challenge. And then we made it to the Sweet 16 in the business plan competition. And next slide. And we built a prototype that was made out of a water noodle. And it was basically, this is the water tunnel at UW. It was a fin that oscillated back and forth on the water. And if you go to the next slide, this is underwater, so it oscillated back and forth. If you click one more time, or maybe two more times to get it started. Oh, try to go back. This is a video that is playing now. Cool. So this is something that can produce hydroelectricity using gravity-fed currents such as rivers or streams, or tidal currents, or oceanic currents. So, okay, next slide. And then finally, we won first place at the Seattle Pacific University's Social Venture Plan competition, winning a grand total of $5,300 in the first 6 months. And next slide, that's, in case you couldn't read the other one. We were recognized by Fenwick & West, which is a rather prominent law group. They offered to do my non-provisional patent, which is like the real patent, for a deferral of equity. So that saved me a lot of money at the time. And then I was invited to speak at a couple different events. That's Emer Dooley, if anybody knows her, or Bill Lemon. Everybody knows Fulbright, though. That was really an honor. So you could skip through. Everybody was quite fascinated. So let's see. PNNL and NREL, they were both given funds by the Department of Energy to validate our technology, and they gave us nothing but good news. Our business plan has changed after almost every competition we were in, and it's mostly because there's such a wide variety of potential applications for us to find and explore the different market opportunities. So go ahead and advance. So this is the second to last prototype I've made, and the reason why the technology works pretty good is the wings that oscillate back and forth can pitch back in a gust or in high winds, and it basically hibernates. It goes dormant. It doesn't produce any energy. It just survives. So this is an example of it pitched back. This is an all-aluminum model, but as I've been evolving my business plan, my current focus is on a customer who is at the village level, who faces high costs and inefficiencies in pumping water from deep wells and using existing electric pumps or outdated wind turbines. So, next slide. With Pterofin technology, I could imagine the product that would have the portability of a diesel generator and the cost structure that is much less than a fixed turbine. With that in mind, did I already run out of time? I'm sorry. I'm building a prototype that directly connects the mechanical pump to a mechanical pump that can be built at a lower cost than traditional wind turbines. Simply put, I hope to outcompete the wind turbine designs that haven't changed much in over 100 years. Thank you very much.